Number 13. This, I hope, looks like an interesting picture to you. It's called a diving bell, and this is an ancient invention described by Aristotle, the Greek, in 4th century BC. And the idea is that you take your air with you. So here's air in the picture, and here's water down here. But if you carry your air in this bell, then you can breathe while you're walking on the floor of the ocean. So now we can look at this as a gas law problem. The air is clearly important to the human. Is this a realistic picture? Specifically, is the water level shown in the bell realistic? So you can imagine at the surface the bell was completely filled with air. So here it is, air. And let's just make a number. It may be easy for some of you if we put a number on there and say it's 500 liters of air. Now, when you go underwater, the pressure will increase. You've all experienced this when you've dived in a pool and at the bottom you say, my ears start to hurt. So the pressure increases as you go underwater. And this information here says underwater pressure increases 1 atmosphere for every 30 feet of depth. Basically, if you go down 30 feet, the water above you will weigh 14.7 pounds per square inch. So now the atmospheric pressure will be 1 atmosphere on the surface. And if you dive 30 feet, it'll be 2 atmospheres of pressure. That additional pressure is transmitted to the inside of the container, which means the air will shrink in volume. So this is like the syringe, double the pressure, means half the volume of air. So this picture is unrealistic. It should be more like this, which is really interesting to think about. That the water will fill this space. The human will still be able to breathe, but it'll be half the volume of air. And the air will be twice as dense. So the human will be breathing thicker air, more molecules per liter. Okay, so I'm hoping that the picture does a lot for you. If you were to write the words, you would say something like the concept is Boyle's law. Increased pressure leads to decreased volume. And specifically, in this case, double pressure equals half the volume of gas. If it were more complicated, you could have ugly numbers. You would use the mathematical equation. Sometimes written this way, initial pressure and volume product must equal the product if the conditions are changed. So here with my numbers, you can see it's very simple. 1 atmosphere, 500 liters, equals 2 atmospheres, 250 liters. But you could still walk on the bottom of the ocean, looking at the sea creatures, and carrying your air with you in the diving bell. If the other interesting thing is if you then pull up the bell with the human, the air space, this air space here, as you pull the bell up, the airspace will expand and will end up with 500 liters of air once it reaches the surface. The second part here is asking you to think now about chemistry. The human respires, meaning the human takes in O2 and uses the O2 to react with things like sugars to produce ATP. Might as well balance the equation. And in the process is making 6 CO2 plus 6 H2O. The CO2 is exhaled. The sugar is it's actually aqueous in the human body, and the water will be liquid. Fine. So this hint is suggesting you that you need to think about what happens now. If it were simple exchange of O2 for a different gas, you should expect that the air here will be different in composition, but the same number of molecules, therefore the same volume. But if the CO2 starts dissolving in the water, so here it goes into the water, then the volume of gases will shrink. So if the CO2 dissolves, becomes aqueous, becomes AQ, then the volume of gas will shrink. So you have a limited time at the bottom of the ocean. You will run out of air. So make sure that they pull you up before that happens.